Good morning, everybody. I am Anusha of CSC department, working as assistant professor in Institute of Aeronautical Engineering. In my videos, I am discussing about programming with objects, which is based on Java. So, in the previous video, we have discussed about exception handling mechanisms, about finally, then how we can create how we can create our own exceptions in Java, and what are the various built-in exceptions available. And in today's video, we are moving into multi-threading concepts. So we look into the difference between multiple processes and threads, the Java thread model, and what is the main thread in Java. So multi-threading means like whenever we want to do some work, multiple works concurrently, then we generally go for the multi-threading concept. So the operating system which we have today are almost all supporting the multitasking. That means when we perform one work, parallelly we are allowed to allowed to do another work. For example, when we are preparing a Word document, we are allowed to browse the web also. So in a different window, you can browse the web. So that is multitasking. So Java supports multi-threading. That means if you have a huge program which can be divided into smaller parts, and each smaller part can be executed by individual process, or we can say individual threads, which is a smaller way of process, then each of these chunks of work can be given to smaller processes called as threads. So what happens here, when there are more than one threads executing at the same time, we can finish that work at a faster time. We can finish it quickly. So that is the main advantage of using multi-threaded programming. So these multi-threaded programs, they contain two or more parts that can run concurrently. And each part of the program is called as a thread, and each thread defines a separate path of execution. So it is a specialized form of multitasking. This multitasking is of two types. One is process-based and the other is thread-based. So let's take an example of reading an array, and we have to perform the sorting calculation. Let's say calculate the sum, and we have to search for an element. So these three can be done if we are using some C program or C which doesn't support multi-threaded programming. Then these programs we have to do it linearly. That means after the completion of one method, only then we can move on to the second method. Right. So after reading, we have to sort it. After sorting only, we can go for calculating the sum. After that only, you can go for searching an element. If we are using a multi-threaded program, if you are not using a multi-threaded programming, if you are using simple structural programming. So here, these methods, they are working independently. This sort method is nowhere related to finding the sum of the elements. So what we can do, we can separate these methods and give it to different threads. So that is why after reading, so when you go for multi-threaded programming, we can make use of finish the program, we finish the work quickly, wherein you have the after reading the array, you have the sort method to implement the sort method to sort the elements. Then you can use another thread to find the sum of the elements, calculate the sum of the elements, and you can use another thread for searching the elements. And after all these things are done, you can make use of the print method to print all the output. So here we are making use of three threads. So this full thing, this full thing forms one process, and inside that process we are making use of three threads, by which you can enhance the speed of the operation. So in process-based multitasking, it allows the computer to run more than two or more programs concurrently. That means it can execute more than one program at a time. So in general, when a process is a program that is under execution. It is a smallest unit of code that can be dispatched by the scheduler. For example, when you run Java compiler, you can use a text editor. You can use a text editor like MS Word, or you can browse a website. So this is an example of multitasking. Now, similarly, if you go for thread-based multitasking, we can say that thread is the smallest unit of dispatchable code. A single program can perform 2 or more tasks simultaneously, and it is a lightweight process. So, for example, if you take a text editor, while editing itself, you allow the printing of another document, but you can also edit one document. So there are 2 actions being performed by 2 separate threads in that process. So if you look into the comparison between the thread-based and process-based model, thread-based are less overhead, but process-based are more overhead. They are light. The threads are lighter in weight since they share the same address space. And share the same heavyweight process. So inside one process, you can have multiple threads. So one process will have one address space. That address space only will be shared by these threads. But if you go for processes, they are heavyweight tasks, and each process should need their separate address space. Since since they don't, the threads share the same address space, the inter-thread communication will be inexpensive, whereas inter-process communication is expensive and limited. Now, similarly, since in thread-based they come inside the same process, in context switching from one thread to the other one is lower in cost, but whereas context switching is costly in process-based tasking. Now, this multi-threading enables you to write efficient programs that makes maximum use of the processing power of the system, and because of which it makes the idle time very less, and it is mainly used for interactive and networked environment. Now let's look into the Java thread model. So as I have told you, multi-threaded program will contain 2 or more parts that will run concurrently. So this multi-threaded programming, it enables you to speed up the applications and to take maximum advantage of parallelism of hardware and the inefficiencies of object. The idle time created when a thread reads data from a network or waits for the user input can be utilized elsewhere. When a thread is blocked in a Java program, it will be the only thread which will be blocked by not interfering in other threads. So if we have in a process, if we have 3 or 4 threads, and if one of it is blocked, it will not cause the blockage of the other thread. So so other threads can continue with their work. So this is an advantage of using multi-threaded programs. Now, these are some of the benefits of making use of multi-threaded programs. It is having improved throughput. Then you can have superior application responsive, because the entire application will not get blocked or have to wait for the pending request. or the completion of another request. Then it improves the server responsiveness by large or complex requests or slow clients don't block the other requests for service. Then it minimizes the system resource usage, which threads impose a minimal impact on system resources. It requires less overhead to create, maintain and manage than a traditional process. It also simplifies the program structure, if you are developing a server class or multimedia applications. These simple routines can be written for each activity, thus making the complex program easier to design and code. It also have better communications because we can make use of thread synchronization functions to enhance the process-to-process communication. And also, since these process lies within the same address space, it will have low latency communication between separate tasks within an application. Now, in Java, the Java thread model, there have several states. There are different states in Java thread model. They are new, runnable state, suspended state, blocked, and terminated. So if you look into the diagram, we have the new state. Whenever a new thread is being created, it will be in the new state. So the thread has not yet begun its execution. So whenever once the thread starts its execution, it moves to the runnable state. When the thread start executing, it move into the runnable state. So it is either currently either currently executing or will execute when it gain access to the CPU. Then from the runnable state, it may move to waiting state or the blocked state. It may go to the waiting state when when a thread that has suspended the execution because it is waiting for some action to occur. For example, it is when a wait or a join method is called, then that thread may move into the waiting state, and it may move into the blocked state when that thread has suspended execution because it is waiting to acquire a lock. So when it is waiting for a lock, to obtain a lock, then it may move into the blocked state. And once the thread completes its execution, it moves to the terminated state. So these are the various states of a thread in Java. Now, next is the main thread. So we have seen what is multithreading. So whenever a Java program starts its execution, the main thread will start executing immediately. So whenever a Java program starts, a thread called as main thread will be executed. So a thread called as main thread will be executed when a Java program starts. So it is from this main thread, another threads will be created. The child threads can be created from the main thread, and it is the main thread that will be the one which will be completed at the end. That is the thread which has to finish the execution last is the main thread. Now, if you want to create an instance, or if you want to get a reference to the currently executing thread, we make use of the object current thread. So by making use of this method, we can create a reference to the currently executing object. Now let's look into an example. So here we are having this class current thread, and we have this main. So once this main thread is main started executing, it will create a main. It will create a thread, right? So it will create the main thread. Now we want to get the details of that currently executing thread. So to get that, we have to create an object using the current thread method. So we are creating a reference to the current thread. So using this statement, we are making whatever is the current thread execution. That is, it is the main thread that is being executing. So it is the main thread that is executing right now. So when you create this, T will point to the current thread, that is the main thread. So we just display the current thread T. So when you display it, you get like this. You get the output like this. So it states that one thread is being executing and it is of main type. The name of the thread is main. Its priority is 5, and the group of the thread is also main. So if we so these are the three parameters which will be displayed by the thread thread object. Okay. So here it will display the name of the thread, the priority, and the group in which it belongs to. So here now we have this. We displayed the current thread. Now we are resetting the name. We are changing the name. It was initially main. Now we are changing that name to something else. So here we are setting the name to my thread. So we use the method set name over the thread object. So so T is pointing to the main thread. So we are setting the main thread's name to my thread, and we are displaying it. Right. So after name change, we get like this. The thread is my thread. So here we have the this is the name, again the same priority and the same group. We just changed the name of the previous, the same thread. Right? Now, after name change, then we are opening a try catch block. So inside that, you are printing the values from 0 to 5. Okay, so we start from 5 and we end up at 0. When the element becomes 0, we stop it. So we are displaying the value of n. So in first case, it will display 5. When n is 5, n is 5 is less than 0, true. So it will get into the for loop and display the value of 5. So we get 5 in the output. Now that thread is put to sleep. So after displaying 5, it will wait for some milliseconds, and then only it will display, it will increment the, it will decrement the for loop. So we have the for loop, n values is decremented, n becomes 4. 4 is again greater than 0, 4 will be displayed. It will again wait for some time since sleep is called. Then n value will be decreased. Now n becomes 3. It will display 3, again wait. Again it waits, and then now n values is decremented. N is 2 now. N value 2 is displayed. 2 is displayed. Again wait. After waiting for some time, after waiting for 2000 milliseconds, it will decrease the value of n. Now value becomes 1. 1 is again greater than 0. 1 is displayed. Again it will wait, and then when n values is decreased, n value becomes 0. So 0 is greater than 0, it is false. So the statement, it will come out of the try block. So since there is no exception thrown over here, nothing will be, the control won't be going into the catch block, and it will be finished off properly. So we make use of the set name method to change the internal name of the thread. Then the sleep method is called, it will make the thread to sleep for the specified milliseconds. So it will be put that thread will be put to sleep for so much milliseconds, and the interrupted exception will be thrown if that sleeping thread is interrupted by someone. Then the output of the thread will be shown like this. When you display the features, the first element shows the name of the thread, then its priority and its name of its group. So by default, the main thread priority is always 5, and which is the default value, and the thread group represents a set of threads which can be again included in other thread groups, and it forms a tree in which every thread group has a parent except the initial thread group. So a thread is allowed to access information about its own thread group, but not to access information about its thread group's parent thread group or any other thread groups. So that is all for today, and for preparing these videos, I have made use of the textbook complete reference, and I have referred the Java tutorial by Oracle and the Java T-Point website. That is all for today. Thank you for watching my video. We'll meet in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.